All right, welcome to the Daily Space Weather, folks. Exciting stuff going on all around. And we're excited to be here streaming live on Twitch. Thanks to everybody who's tuned in, whether live or in syndication. By the way, the track you're hearing is Wind Chime Madness, and that is located on the SoundCloud page. Click the links to find it if you like. Let's move on to solar data. Here's some SDO data. Let's look at the northern hemisphere of the sun in 171 angstroms. A little bit of magnetic filamentary interaction going on in the northwest. 0 sunspots. No significantly defined coronal holes in the Earth-facing region right now, although we are right at the beginning of a coronal hole wind stream, so it's just started to hit. And we just saw the ramp up in velocity following a short ramp up in density. And there's the southern view. Little bit of filamentary activity there in the southeast as well, near my pointer. And let's move on to 304 angstroms. There's the south region, complete with date stamps. Just in case you want to look up any of this stuff yourself, it is all available on the SDO page, which is linked below the video as well. And here's the northern hemisphere in 304 angstroms. Again, no sunspots. And a coronal hole wind stream is just in the process of hitting right now. Here's the real-time solar wind data. Solar wind density, 7.64 protons per cubic centimeter. Solar wind speed, 456 kilometers a second. And check this out, we got all the way up to a steady stream of over 20 protons per cubic centimeter there, folks. In the 20 to 35 proton range there. So a bit of a uptick there, and we see that pop back down as the velocity pops up. A typical signature of a coronal hole wind stream. So it's here, and it's not having a lot of effect on the magnetosphere. We'll get to it in a moment. First, look at the ACE data. And it's looking corroborative, except for one thing. Check out the phi angle. ACE showing completely different phi angle data. Perhaps seeing a different angle. I'm not sure. Those don't look like anomalous signatures at all. Anyway, here's the magnetosphere movie. And here's a clip from Scarface that's all reverbed out. Let me turn that down. Yes, we've made significant changes to it, and we won't get copyright struck for it. Anyway, there's the 4 hours of the magnetosphere movie. And we see a little higher pressure than we have. And here's the ground geospace magnetic perturbations. And we're going to talk about the global magnetic map toward the end of the video, so stay tuned for that. We're going to have a quick blurb and leave links. And we see significant perturbations over both the north and south geomagnetic poles. Let's let that play through a second time. In preparation T's to see that magnetic data. Next, we're going to look at the ionosphere movie, 6 hours as we do. Excuse me. Let me just make sure I loaded the right stuff there. And there you've got 6 hours of the ionosphere. And we still do see minor charge-up anomalies there over the South Pacific. Ionosphere charging up at nighttime, south-southeast of Hawaii, and it's been doing it for weeks. Although it seems to be diminishing a bit as we approach the solstice. By the way, what are you doing Saturday night? We've got ideas. Let's talk about the 10.7 centimeter radial flux. It is a proxy to sunspot number in terms of solar activity. Currently at 71 solar flux units. As we approach the new year, goes electron flux very low, and you can see it cratered to the bottom of the measurable point here a few times yesterday. And you can see it's flatline. That means it's got a lower level than it's able to measure. And that is especially low at the GOES 16, a little bit higher at the GOES 14. Very low levels of electron flux. Relativistic electrons also at quite low levels. And we expect GPSs to work well. Here's some of the sawtooth spikiness that we've seen, that we actually forecasted in terms of the GOES magnetometer data. And that's the kicking in of the solar wind. Here's the Gong 2 data. And we're anticipating a polarity crossing in the next 24 hours. So expect to see continued spikiness on the GOES magnetometer as a result of that. In fact, we could only be a couple hours away from the polarity crossing, as this plasma thins out. You can see this plasma here blocking the field force lines. That plasma there, once that starts to move out, if that's not replenished at the back end, the Earth's field force lines could suddenly snap all the way across to the South Pole oriented portion shown here in red. Let that play through one more time, and then I'll show you the last frame. And there's that last frame, and you can see that this force line is going to snap across quite quickly here, and it just happened at stereo A. Stereo A got a little bit confused, so don't be surprised when you see extreme spiky data in the GOES magnetometer, as the electron flux is going to crater. It's going to continue to be ultra low for the next 2 days. The next 2 days, for all throughout today and tomorrow, electron flux will be very low. Then electron flux will increase in about 36 hours. What are you doing on the solstice? So we're only 3 days and 18 hours away when we did the stream. And we will be doing a stream starting at 11 p.m. Saturday night. So bring in winter the right way. We'll be talking about all kinds of real-time stuff, and inviting everybody to chat and talk about whatever they want. We expect to stream live on YouTube and Twitch and possibly Facebook all at the same time. It could be a thing, as we are expanding the operation in various ways. By the way, check out the channel on YouTube, youtube.com/smAsho. We've got related content channels there. Sky Scholar, Electric View, Adapt 2030, Thunderbolts Project, Tony Heller, SDO, and Tess Clark with her audiobooks. And please press like and subscribe if you enjoy the content. Perhaps share on your social media. Let's do the earthquake rundown. Past 24 hours of earthquakes include no 6+ magnitude quakes. We do see some deep quakes, a bit of a swarm in the Caribbean, as well as a quake near Fresno. And some seismic activity continues in Alaska as well. Also, Oceania and Japan get some quakes. I'm just going to scroll up the list so you can read for yourself. There's a deep quake at Alaska. Here's a 4.2 magnitude quake at New Zealand by the South Island. We haven't seen so much activity there. So that's a deep quake in a location where we haven't really seen too many quakes. Here's a deep one at Japan. That one nearly 400 kilometers depth. Here's an Albanian quake. And we've been seeing a quake near Albania every about 3 weeks for the past year or so. Another deep quake near Japan. Let's see, this must be one of the largest of the past 24. This 5.3 at the Philippines. I think there might be a Chinese quake there too. Let me see. Here's one at New Caledonia. Here's a deep quake in western South America. Second deep quake in western South America. Very deep quake by Fiji. Looks like south of the island. Dominica sees a deep quake. It's only a 3.3 magnitude. And another deep quake just hits Chile. That one at 4.9 magnitude. How close to Easter Island was that 5.5, folks? Let's check out the map. A very strange portion of the world. The area west of Chile. Not sure where Easter Island is. Is that it down there? I have no idea. Anyway, that's where that 5.5 was located. I believe that was actually the largest quake of the past 24. That one at only a 10-kilometer depth. Let's look at windy.com's pressure maps in real time. And we are stoked to be back to live streaming, and we intend to be multiple platform live streaming soon. So stay tuned for all kinds of changes coming, folks. Let me bring that back. Anyway, there's the current pressure cell situation. Pardon me, I'm biased to the Northern Hemisphere. Shout out to Southern Hemisphere viewers. Thanks for tuning in, everybody, in various countries around the world. We got to get our pals from South Africa back and playing enemy territory, perhaps. Anyway, here's where pressure cells will be in about 24 hours from the making of the video. And it's currently 4:37 where I am. And we are frozen out. There we go. It's very cold across most of the U.S. except for North and South Carolina and eastern Georgia. Check out the temperature anomaly. Got places that are 12 degrees Celsius below normal. And let's just move this ahead as we see very cold temperatures about to hit Pennsylvania, where I'm located, which is in the Lehigh Valley. And then some hot temperatures coming in. Very hot temperatures. Get ready for the news about global warming. Maybe Greta's going to come to visit us in here when the temperature is 12°C above normal. Just after Christmas. It's going to be a warm, warm Christmas, folks. Check it out. Jeez. High temperatures. Although currently, right now, the planet's so hot that it's cold across most of the U.S. Anyway, here's the volcano rundown. Kluchevskoye back on the list. Back to erupting, producing a 20,000-foot ash plume. And that one's very far north, folks. Can you say high-pressure atmospheric compression? Mount Aso, possible activity there. Sakurajima, flight level 7,000. Sanjiang-Api, flight level 8,000. Tukono, flight level 7,000. Popocatépetl, volcanic ash observed in webcam. Sangay, producing a 19,000-foot ash plume. Revenador, 16,000-foot ash plume in Sabancaya. Exploding 30,000-foot ash plume there in Peru. Please do not attempt to do the triple Lindy over Saab and Kaya. Here's one of your value-added services. Courtesy Weather Underground. It's the U.S. Doppler radar map. And shout out to Weather Underground and David Schlotauer. We won't go more in depth and step on your toes. We've got a little bit of eastern lake effect snows and some heavy storms over Florida. Let's check out the real-time lightning maps at lightningmaps.org. Your source for knowing where the lightning's going to strike. Or at least where the lightning just did strike. And we don't really see any there. Check it out. No real lightning over those storms over Florida. It's just heavy rain, folks. Although we see some errant lightning bolts in the North Atlantic. And the Gulf of Mexico. Anyway, here's the U.S. water vapor map. This is the NASA GOES interactive weather satellite, if you were wondering. And we see a long chain of very dry air all the way from Nova Scotia. Shout out to Ricky, Julian, and Bubbles. All the way from Nova Scotia, all the way down to the South Pacific off of the west coast of Mexico. As well as a bunch of moisture swirling in, being yanked southward by the jet stream. So get ready for some warm temperatures coming, folks. Here's the nullschool.net jet stream maps. And all I want for Christmas is more bicycles, aka bicycles that work. As practically every vehicle that I own is in the freaking shop. Even my skateboard has a cracked base plate. Do you ever feel like you needed a new everything? Hopefully you don't need a new jet stream, because that's the only one you're going to get. Powerful anticyclone still off the west coast of Greenland there. I would add, as well as extreme bends in the jet stream. No kind of organized jet stream, folks, for years. Here's the eastern world. Don't freak out, folks. Cycle 25 is already underway, and I mean solar cycle 25. And welcome to space, and welcome to the Neo-Renaissance. As science gets rewritten, here's where stuff is in the solar system. Milky Way galaxy team of other wind. Here's where things will be in a week. And by the way, shout out to our patrons. Here's the new mouse. It's super badass. Watch, when I change the refresh, the DPI rather. Change the mouse colors. Here's all our different colors. So cheers, thanks patrons, and we're upgrading things, and we're not providing a balance sheet or anything like that. Keep in mind these are all voluntary. Yes, these are all voluntary submissions, folks. Looks like it's going to be a new moon on Christmas, by the way. I don't know if you care. Here's where stuff is above my head. I like to use in-the-sky.org's sky map. And it's 4:20. Do you know where your moon is? By the way, you can animate this if you want to know when Mars rises, which it just did. It's still in Libra. And then you'll see Mercury rising right after that. And then you'll see the Sun rising. And then you'll see Jupiter rising. And then you see Saturn rising. And then you see Venus rising. It's a cosmic pile-up, folks. By noon, there'll be all kinds of objects up there. You just won't be able to see them because somebody will be obscuring them. By the way, look for changes coming to smashomash.org. And that means you, smAsho staff, Shout out to BMVR13. Holla! By the way, I don't know if you're aware, our channel is funded primarily by our patrons. As we have zero financial relationship with Google, YouTube, entities like that. So please consider becoming a patron, support the content, as it's in an ever-changing ground-level process. And there are going to be game servers and chat rooms and forums and merch and all kinds of things that you just may not be aware of. So check out smashomash.org. And again, look for the forum coming soon. And thanks again, patrons. Here's what the merch is going to be. This is going to be the first smAsho merch that we make. The 3C405 shirt, which features Massive Radio Galaxy Cygnus A. And, of course, a link to the .org website. And we are going to make your donations tax deductible. Not by the end of the year, but very early next year. Let's talk about things that are fast. The sailfish. Now we've got 3 fish here, 2 goldfish and a pleco. And we're about to upgrade one of the tanks. The pleco will have a 29-gallon tank, and the goldfish will have a possibly up to a 150-gallon, I think more like a 120-gallon tank. And so we're very interested in aquatic life forms. And shout out to Rodrigo Fricione for this fantastic photo of a sailfish fishing. Now these things are believed to be able to swim at about 70 miles an hour. And there is a little bit of argument about what the fastest fish is, but it's fairly believed that it's the sailfish. Let's talk about slow things. Magnetic pole shifts. And this slow thing has been accelerating to a kind of a fast thing, as the world magnetic model has been updated. And the North Pole appears to be continuing to push towards Siberia. We've left links to the article at phys.org, as you'll see this all over the science publications and on YouTube. And of course, this is part of the reason why we watch the geospace magnetosphere movies every day, because we want to see each individual pulse on this channel. And believe me, we understand the implications. Anyway, if you're up in these regions trying to use a regular old magnetic compass, let's just say you'll get some oddities, depending on solar activity, what time of day it is, and all kinds of other factors. So just keep that in mind if you're planning on going to any polar regions. Now, of course, most people aren't doing things like that. There's a reason why practically nobody lives there, and we won't get into all the physics of how biological life is affected and so on. However, it is affected. And it largely has to do with the way that solar radiation affects water. And anyway, links to the phys.org article below the video. As we got to keep moving on here, I have no idea how long this thing is. And thanks for everybody leaving the comments. Here's the associated data releases from NOAA. And of course, we've linked this below the video also. The 7 components that they're computing are total intensity, horizontal intensity, north intensity, east component, vertical component, geomagnetic inclination, and geomagnetic declination. So these are all things that are also involved in the geospace magnetosphere movies, the University of Michigan data that we look at daily on the channel. And yeah, so there's software you can download. There's zip files. There's a zip file, whatever. Download it if you like. And dear Dr. Robitaille, did you get our email? We hope this is still the right address. But trying to get you on the show to talk about the implications, mainly about the implications on the condensed matter model of the sun, the liquid metallic hydrogen model of the sun, on cosmology and how it relates to all kinds of things from relativistic jets, active galactic nuclei, etc., to the generation of the Earth's geomagnetic field. So that's what we're interested in, is the implications to cosmology regarding the 40 lines of evidence for condensed matter, the sun on trial, liquid metallic hydrogen as a solar building block. I challenge you, Ben Shapiro, to talk faster than me. Let's talk about NGC 6338, a massive elliptical galaxy. It's really a cluster, and it's located at quite a great distance. I don't know exactly what the distance is believed to be. Here's a close-up image of it here. This is, I'm not sure exactly which image this is. Looks like visible light. And apparently this is really two galaxies that are speeding toward each other at 4 million miles an hour. Chandra's just released a video about it, so check that out in your spare time. You can even download it, as it's created a whole bunch of star-forming regions, X-ray producing regions, and so on. Let me play a clip.
Clusters of hundreds or thousands of galaxies to each other at a remarkable speed of about 4 million miles per hour.
So there you go. That's a part of the animation there of NGC 6338. Courtesy chandra.harvard.edu. Yes, Harvard University. So have a read of that article if you like. Let's talk about the Earth's interior structure. Bridgmanite is a magnesium iron mineral with a crystal structure that is not stable under ambient conditions. It forms about 660 kilometers below the surface of the Earth, and microcrystalline grains found as inclusions in meteorites are the only samples ever recovered on the surface. Please leave a comment if you think that sounds like conjecture. I mean, geez, that is crazy. The only evidence of this ever seen on the surface is in meteorites. So they must be in the center of the planet if they've been seen in meteorites. I mean, you gotta believe that. I mean, plus, how about the idea that the Earth's magnetic dynamo is generated by a nickel-iron liquid core, where there are multiple layers of iron and other materials spinning at different... It's a ridiculous idea. I mean, first of all, iron is not magnetic when it's liquefied. Ever hear of the Curie temperature? In any case, it's a cute article, and seismic waves behave funny in certain regions of the Earth, and let's just leave it there and not attempt to draw any conclusions or get hip deep in the weeds on this. Just have a read of the article, and I don't know if you've got a salt shaker, bring it along. Now, yesterday we talked about synchrotron radiation, as synchrotron radiation is kind of important in cosmology as it's associated with relativistic jets and things like poloidal fields. A lot of people out there seem to think that toroids are the source of everything in the universe. Here's a diagram of toroids versus poloids. So in this case, and shout out to Ben Davidson, so your toroidal field here is the orange donut shaped, and the toroidal flow would be the blue arrow here, flowing around the field. This is what the Earth does in the interplanetary magnetic field. Then you have the poloidal field, and nobody's really sure on a cosmic scale how these things interact. Is the toroid field the source of the behavior of the matter in the system, or is the poloid field? Now, this is a very, how do I say it, counterintuitive scenario, and we can't differentiate the two, as Ben Davidson aptly stated in his comments yesterday on his Suspicious Observers video, that we're not exactly sure what the interaction is. Does the poloidal field cause particles to rain down and become the toroidal field? And what are the implications as to the sizes of these fields on a cosmic scale? So how big are the sun's poloidal fields, the ones that come out of the poles? How big are those in comparison to the toroidal fields? Now, my theory is that the poloidal fields are hundreds of times longer and larger, an indication that the heliosphere is not shaped anywhere near the way people think it's shaped, because there are, let's just say there are points in the heliosphere, I believe, that are much closer. So if this was the sun's toroidal field, the one in which you live, the heliosphere is going to dip all the way down here into the sun's Z field, which means there's probably a zone of inactivity kind of in the center of this poloidal field. And again, the poloidal flow is the red arrow in this. So the toroid flow is the blue arrow, and the poloid flow is the short route around the field, in this case shown in red. Now we know that active galactic nuclei, they act like fountains. They don't just suck things in like a vacuum, folks. That's not the way a black hole, which we refer to as a massive radio source, they don't just act like vacuums, folks. In fact, they don't really act like vacuums at all. It seems like repulsive forces are largely at play at most layers. Now, it's fairly obvious that protons run the universe, as when you have a string of protons, the protons will repel each other, depending, they're going to be ionized. You've got a cloud of 100% ionized gas. If you apply pressure or heat to the back of it, it's going to push the rest of the gas away from itself. And we're not going to get into the way magnetohydrodynamics works, or why it is that electrons are where they are, as I think we covered that in yesterday's video, if you want to hear about synchrotron radiation. Now, here's an image from the Gong 2. This is the line of sight field plot, and you can see the toroidal field shown here in blue. That's the sun's B field. And then you can see the Z fields shown here in green and red, North Pole green, South Pole red. And what we're talking about here is how much of the interaction is caused by how much of what's going on in this blue field is caused by these fields, or is it vice versa? And ultimately, since we don't know whether the sun, the Earth, or the galaxy, indeed, are gaining mass or losing mass, it's an important question to ask yourself, because the most pressing arguments in all of physics are always chicken versus egg. Now, here's a great example of a poloidal field line where we can see relativistic jets coming out of galaxy M87, a massive radio source, at a great distance. And you can see clearly there's illuminated plasma here along the entire axis of this field. The idea that the plasma creates the field is just ridiculous, as when you have ionized gas in space and you apply a magnetic field to it, it gets heated up by the magnetic field. It does not become the magnetic field. It's not transmitting the magnetic field. Gas can't transmit a stable field like that. The gas orients to the field. It doesn't become the field. Does that make sense? Anyway, the pulses that you see in here are different proton-electron densities, really proton-electron ratios. And let's just say the electrons follow the protons. And we'll get into that in more detail on a later video for sure, as it's super important and super obvious if you simply monitor solar data. So links to all of these pages will be below the video eventually, once it premieres on YouTube. And there is another one here from the SDO, one of the channels that we feature And this one just talks about, it's just animations of the believed solar dynamo, the mainstream version of the solar dynamo, as well as the toroidal and poloidal fields. So the poloidal fields are the ones you're going to see coming out of the poles, obviously, and the toroidal fields are the ones you're going to see coming out of the equatorial region. And it's going to go through a sunspot cycle, as the toroidal fields are kind of associated with sunspot activity. And I don't know, the video's not playing. What is up with that, YouTube? Geez, Google, fix your software, for goodness sakes. Anyway, there's some bit of a teaser from the SDO page. It almost kind of wanted to load. And one other note here is that perspective is super important when you're looking at a galaxy as an edge-on, cigar-shaped edge-on disk. This is kind of the view you're going to see. You're going to see the jets coming out. M87's jet is an example of this. Here's the toroid field. Here's the poloid field. We call them Z fields. That's the poloid, or B fields, which would be the toroid, if you're talking about things like the sun and the earth. As these objects all are somewhat fractals of each other, and thanks Smash team, we got to get out of here as this video is getting kind of long. Too much science explained. And we're moving on to the 335 angstroms view here of the local yellow dwarf. And that's 48 hours of the latest in 335 angstrom activity. Please leave a comment if you've got a message to be sent to your local yellow dwarf. We'll transmit it on the channel. Also, leave a comment if you think the sun's conscious, as most ancient cultures did. I neither believe nor disbelieve that the sun is conscious. Let's just say it's got a lot more electrical connections than your brain has. There's a lot more chemistry going on the surface of that thing than there is inside your brain, folks. Anyway, have a delightful day. Please don't forget to press like and subscribe. Please share the videos on your social media and become involved in our organization on the ground level, as we do all kinds of things you weren't expecting. Also, please join us on Saturday night, 11 p.m., when we live stream on at least YouTube and Twitch. So shout out viewers, thanks patrons. Remember to stare at the sun. When you're doing so, don't drink, and certainly don't drive. I mean, the colder and snowier that it gets, folks, during now the darkest week of the entire year, or the brightest if you're in the southern hemisphere. Anyway, don't drive. It just raises your statistical probability of death. Stare at the sun, use the proper instruments, and since it'll never be now again, may that solar wind be at your back and that atherosclerosis absent from your veins.